I'm Nipun. I'm going to talk about generative AI. I'm going to talk about the piece which Wim a little bit rushed through. So before I get to generative AI, let me just do a little bit of a recap about HeatWave. So what HeatWave is a fully managed data processing service. It is designed to process data which is either stored inside the MySQL database, transaction data inside the MySQL database, or data which is in the object store. And the reason I say it's a data processing service is because it can do multiple things. It can obviously do transaction processing. It can do analytics. It can do machine learning, generative AI, autopilot, which uses machine learning internally to automate various operations. Now, today's focus is predominantly going to be on machine learning, vector store, and generative AI, but I just want to make sure that you're aware of what the overall picture is. The second thing, which is also very key, is when the data is inside the MySQL database, obviously all tools and applications, which are like a lot, right? I mean, you saw in the introduction, like almost like 1 billion downloads of MySQL. So all the tools and applications obviously work when the data is inside MySQL, and this data or the instance can be on-premise or in the cloud as HeatWave. But the interesting thing is that even if your data is in a file in the object store, all the existing tools and applications which work with MySQL will continue to work. Right? Because we are adhering to the MySQL semantics, we have enhanced the MySQL parser so that it can interact with content inside the database. So the only thing which you won't get for your application when the data is in the object store is transaction semantics. Right? So if you need transactions, sure, the data needs to be inside the database, but otherwise, the rest of all the functionality which you're going to talk about is available both in the object store as well as inside the database. And also keep in mind that in the object store, we can have all the three kinds of content. We can have structured content expressed as CSV, Parquet, Avro. It can be semi-structured, expressed as JSON, or it can be unstructured. Right now, we are starting off with documents like PDF, PPT, and such. But as Vin was alluding to, we do plan to enhance the support for unstructured content in the object store. And one of the ways we see a lot of our customers deploying is if customers have, say, some transactional data, which for whatever reason, they don't want to move to HeatWave. And transactional data is typically very important. Transactional applications are very mission critical. So it's often the case that customers say, you know what, I'm going to keep my transactional database as is, for instance, SQL Server, but for running analytics or for running machine learning, they want to use HeatWave. So what they do is they keep the data, the transactional data in the existing database, using some service like Golden Gate service. They copy the data from the existing relational database into the object store because the object store provides a very inexpensive form of storage, very durable form of storage, and then they use HeatWave analytics or machine learning or generative AI on this content which is in the object store. So they get best of both the worlds. The existing transaction system continues to work as is, but they can also leverage the capabilities, the performance, and the price performance benefits of HeatWave for analytics and generative AI. Now, one of the reasons, I mean, I'm going to talk in more details about what we have in support for generative AI, but one of the things to note is that if you were to try to build a similar application in AWS, you will have to use a number of different services. You will have to use Aurora for transaction processing, Redshift for analytics, you'll have to use SageMaker for machine learning, Bedrock for generative AI. And this significantly increases the complexity for the application. It increases the cost for the application. It reduces the performance because you're having to move the data around, and the application is not very secure. Because in the best case, your application is going to be as secure as the least secure service. But chances are that if someone is going to exploit a security vulnerability, they're going to exploit the various kinks in the various services. So by having all the data be present inside HeatWave, either in the object store or in the MySQL database, and doing all the processing inside HeatWave, you get a lot of benefits. Benefits of performance, benefits of security, reduced complexity. Now, if you want to just see, like what is the advantage in terms of performance or price performance you get with HeatWave or customers get with HeatWave, here is a comparison of half a petabyte of data. So Wim was talking about how currently a single instance of HeatWave can process half a petabyte of data in memory. This is a comparison of HeatWave, half a petabyte of data, comparing with Snowflake, Redshift, BigQuery, and Databricks, and you can see the price performance advantage your applications would get is anywhere from 5x to 30x. Okay, so I guess I just want to be clear about this point that I'm going to talk about generative AI, but this is all in cohesion with all the existing capabilities we already offer in HeatWave, transaction processing, analytics, and such. Now, there are three things which we offer from an AI ML perspective in HeatWave. One is a support for auto machine learning, right, or auto ML. Here, what the system does is it automatically creates a model for you, which means creation the model means determining which is the best algorithm to use, which is the best set of features to use, the hyperparameters to use and such. So the main benefit is really being able to fully automate the machine learning lifecycle. That's the first thing. We support all the interesting or the important use cases, for instance, classification, regression, or the various tasks. Most of the times we see that customers use not one, but at least two of these tasks. And it's hard to say which is the most important or the popular one, but I would say anomaly detection and recommended systems, if you were to ask me, are probably the most two popular ones. And what is interesting is that not only is the machine learning inside HeatWave fully automated, it is also significantly faster than the competition. So training a model with HeatWave is 25 times faster than with SageMaker. Now, what is the implication of it being 25 times faster? Well, not only does it take less time to train a model with HeatWave, but if you can train the model 25 times faster, you can train it more often, and what that means is you can keep your models up to date. And if you can keep your models up to date, it then improves the accuracy of the prediction, right? So having the training be done faster encourages customers to keep their models up to date, which then influences the accuracy of the prediction. The second capability which we have is vector processing, and this is something which we introduced at last Cloud World. And here there are two aspects. With vector processing, what we are able to do is to take unstructured content and start doing searches on unstructured content. So there are two benefits of this. One is any unstructured content. Right now we are doing documents, but in the future we can do like images and such. You can start doing comparison. But what is interesting is that not only can you do a comparison, you can do semantic search. Because with text indexes or text processing, you typically do a keyword-based search. But with semantic searches, you can do an operation which is just not possible with text processing. So suppose you're looking for the name of all scientists in a document. You do not know who the scientist is. You say, hey, in this document, give me the name of the all scientists. And the system will actually pick that up for you. So semantic search is very rich and very powerful compared to text-based search, and that's what we have. And the third thing is generative AI capabilities, right? So generative AI by name suggests that it can generate content. And a very good example and a very popular example of generative AI use case is summarization. So if you have a document and you want to summarize it, you can't do it with machine learning, right? But that's what you use generative AI or the LLMs for. Another example is translations. Right? That's another example where the system or the model is generating content. And the key thing we are now providing with HeatWave Generative AI is the ability to apply LLMs on enterprise content. Because LLMs are trained on public content. So if you want to bring the power of LLMs to enterprise content, you don't want to train the LLM on enterprise content because then that has the risk of data leakage. So you're bringing the power of LLMs to enterprise content. But guess what? Everyone else in the industry makes an invocation to a GPU to do that. We surely provide that option because it is like about 3 times faster. But what we also do is we have done the work to run LLMs inside the database on a CPU and parallelize it. So this way, your data stays where it is. We do the processing inside the database in a very secure manner. So that's a gist of basically what we have. So now getting into more details, we have support for, as I said, machine learning inside the database. We have had it for about 3 years. This is one area which is picking up a lot of use cases and such. And if you guys are interested, we can talk more about it later. But the thing to note is that we have many customers who are migrating from other clouds to OCI to leverage the benefits of HeatWave machine learning. So the machine learning capabilities of HeatWave themselves are so important and compelling. And one good example is Eat Easy is one of the large food delivery companies in the Middle East. They migrated from AWS, where they were using Aurora and Redshift, to OCI because they really liked the capabilities of machine learning and specifically the automation related to the training of the models. Okay, so now let's start talking about generative AI. what do we have, right? So we have basically 4 capabilities with HeatWave Generative AI. The first thing is the capability to take unstructured documents which are in an object store and creating a vector out of it. So please note, the documents do not need to be inside the database. The documents can be in an object store, they remain in object store. HeatWave reads those documents, does all the processing that is required, parsing, encoding, segmentation, creation of the vector store, and creates the vector store back to the object store. So all the processing is happening inside HeatWave without requiring any external software, without requiring any external hardware, but the data starts off from the object store and gets back to the object store. That's the first capability. The second is the ability to execute LLMs. We obviously can invoke external LLMs like the ones in the OCR Generative AI service, and with that we have a whole lot of use cases like RAG and others. But the other very important thing which we have, or noteworthy thing which is differentiated in the industry, is the in-database LLMs. Right? So the capability to be able to apply the LLMs to enterprise content. And one example could be that you create a vector store and then you want to apply the LLM. You have 2 choices. Either you can invoke an external LLM or you use the in-database LLM. That's the second aspect. The third aspect is when you have created the vector, right, in step 1, you can do 2 things. Either you can apply the LLM, which we talked about, or you may want to just do a semantic search or a similarity search. For that, there are multiple ways of doing it. We have taken the route which is the fastest and also 100% accurate. So when we create the vector, we have built-in operators inside HeatWave which do similarity search or distance function at memory bandwidth. If you're doing it memory bandwidth, it is as fast as any machine can do. But it also means that we are scanning through all the rows, which means it's 100% accurate. So there is no loss involved in doing the semantic search with HeatWave. And finally, to make things easier to get people started, we have introduced a visual way of doing it. So we have extended the MySQL shell with VS Code plugin. And this plugin, what we call HeatWave Chat, can now interact with HeatWave and you can ask questions to the HeatWave engine in natural language. Right? So you can also do it through a SQL interface. That always exists. But in order to make things easier, and you can build your own UI. But if you want something to just get started, we offer this UI, which we call HeatWave Chat, which is a VS Code plugin to MySQL shell, which you can use to interact with HeatWave. So let me give you an example. So this is a company based in LAD, and this company offers online courses. When they started running with HeatWave Generative AI, they suddenly found that the number of customers who were coming to them increased, or the number of hits they had for their courses increased. And the reason that happened is because earlier they were using a text-based mechanism, but now with vector search or vector processing, they are doing a semantic search. So if someone is looking for a course which says, okay, I'm looking for a beginner level course in OCI, earlier the course name had to be a beginner level to do exact match. But now, even if the course says, say, first-time user or introduction to OCI, whereas the search term is like a beginner's level, it will do a match. Right? So this is the power of semantic search, and we have a case over here where within the first quarter, they saw almost double-digit increase in the number of requests coming in, which led to improved business. The second example is an example of an e-commerce application which was built using HeatWave. And the interesting thing over here is that this started off being a transaction processing application where someone is building an e-commerce website. And in the e-commerce website, they are building a system where they're selling merchandise, and they wanted to have a mechanism by which people can provide product reviews. Now, the product reviews are stored inside the relational table inside MySQL database, and that's fine. But what became interesting is that in order to get feedback about whether to get an analysis of this feedback, whether it's a positive sentiment or negative sentiment, the system could do it automatically inside the database. So what the application did was it would fetch this feedback, this content which was provided by the user using JavaScript. It sends it to the generative AI engine, which is invoking an LLM, and says, you know what, this feedback, tell me whether it's a positive sentiment or negative sentiment. We give this feedback, and this is what is used to compile to say, aggregate, look, the positive reviews were 60%. So this is something which is all done automatically. It is done all inside the database. And as users add more data, as there is more content coming in, the system keeps the content and the summary up to date. So this is a very good example which shows the combination of transaction processing, generative AI, JavaScript, machine learning, all working in one application. And this is typically how most of these modern applications are built these days. If you're offering a merchandise, you want to get some feedback on the merchandise and be able to process it. So within the first quarter of going live, we have seen a significant uptake in the adoption of HeatWave Generative AI across all industry segments. I believe there are two main reasons for that. One, all the components which are required to build a generative AI application, both software as well as hardware, are available out of the box with HeatWave. That's the first thing. And the second thing is, in order to build a generative AI application with HeatWave, the user does not need to be an AI expert at all. So as we were showing, and I'm going to show in a little more detail, you make the same call to create a vector store as you do to load data from an object store to HeatWave. Right? So we have completely taken the requirement away that the customer needs to know about AI or machine learning. So a combination of these two things. First, that all the components which are required to build an application, generative AI application, they exist out of the box in HeatWave without any additional charge. And secondly, it's very, very simple to use, specifically doesn't require AI expertise. And because of that, we have seen a huge uptake across various industry segments. And the other thing also I feel is that everyone realizes in each segment that if they're not working or if they're not leveraging generative AI, there's a very high chance that someone else, one of their competitors, is doing so. And you can see even within our team, our organization, and within Oracle, there are many, many applications of generative AI within each team and within each sub-team. So I'll start off with the in-database LLMs, and the reason is because this is very differentiated. No other product in the industry currently provides the capability to run LLMs inside the database or on CPUs. Now, why is it a big deal, and what are the benefits of it? Well, the first thing is that if you're shipping the LLMs along with the database, it makes things very simple. You have the choice to use multiple LLMs. We provide you the choice, but by default, we pick a LLM for you. So right away, you can get started. Now, if you say, hey, you know what? I want to do better, and I know that this model will do better for my use case. Sure, you can pick it. But out of the box, we ship with these LLMs, and based on your use case, we pick which is the best LLM for you. You don't need to worry about having to provision GPUs. You don't need to worry about having a generative AI service which you can use. If you have it, sure, you can use it, but you don't have to. The second thing is the cost, right? Make no mistake, running on GPUs is not inexpensive. It's fairly expensive. What we are finding is, for these many of the initial customers we have, that they start off developing their applications with in-database LLMs. And for the most part, the performance is reasonable. As I said, ballpark, it's about 3 times slower than running on a GPU. But when the time comes to go production, that's when they start invoking the OCI GenAI service or using the LLMs which run on GPUs. But for developing the application, for the most part, they don't really need to have a dependency on the external LLMs, right? So it lowers the cost. Third is the flexibility. Availability of LLMs, availability of GPUs on which the LLMs run is still very limited. So if you look at the number of regions we have and the number of regions where OCI GenAI service is available, it's something which is fast growing, but it's not available everywhere. For instance, in dedicated regions, it takes time. The advantage with in-database LLMs is that wherever HeatWave is available, you can run these in-database LLMs. So what it means is wherever HeatWave is available, which is pretty much like all public regions and all dedicated regions, customers can build generative AI applications with HeatWave GenAI. And finally, security. I can't overemphasize the fact that customers want to do all of these cool things, cool processing with this data. The size of data is increasing, but security is paramount. By having the processing be done inside the database provides you the highest level of security. Okay, so there are multiple steps from the time you take so when you have documents or when you have unstructured data, the first thing you have to do is to create a vector. And there are multiple steps involved. You have to parse the document, you have to generate the embeddings, and then you have to insert the embeddings. I've made it simple. Actually, there are more steps. You have to parse, you have to do segmentation and such. All of this thing is automated in HeatWave. And as Wim was showing, you don't need, there are multiple steps which one would have to do. But with HeatWave, you make a single call. You make a single invocation to create a vector, and you make a single invocation to use an LLM on the vector. Not only is it very simple, we have spent many person years doing the optimization so that the parsing, the segmentation, the encoding, these are all parallelized. And by parallelizing them across the cores of a machine and across different machines, not only do we utilize the machine the most, which gives you lower cost, but it also gives you much better performance than you would get with off-the-shelf products. So here's a third party which did a comparison using HeatWave Generative AI to create a vector store with the AWS Bedrock. And the y-axis over here is in hours. The performance of creating a vector store with HeatWave was up to 30 times faster. Right? So 30 times faster, and basically there is no cost for HeatWave, but even if you were to provision a cluster just to create the vector store, it would be 1/4 the cost. The second aspect is that it's typically the case that you will start off with some documents, and then over time you will add more documents. The system can automatically determine which documents have changed and update only those documents. Right now what we have is incremental. You have to specify that, look, these are the new set of documents which have come, and it'll just update those documents. But what we are working on is automating this aspect, so you don't even need to tell the system which documents have changed. That will be done automatically. But we already have a case right now where we are working on a project with there, let's say 10 million documents which have come in. We have created a vector store. Now there are 100,000 documents which have come in. We don't want to keep rebuilding the vector store. So the fact that we can build it incrementally provides a lot of benefit. Now, as Wim mentioned, when we are executing the LLMs, we can execute the LLMs which are available, any of the LLMs which are available in the OCI GenAI service, and there are many of them, and that's something which is always like improving. Or you can use the in-database LLMs. We currently ship with 2 LLMs, Llama, currently the version we are using is Llama 3.2, and Mistral. Now over time, we will make sure that we are keeping up with the latest versions of at least these 2 models, right? So earlier we were having Llama 3, and in the last 2 quarters, we have updated with Llama 3.2. And we are also open to the fact that if there is some other interesting LLM which we feel may be worthy of incorporating inside the database, we can also consider that. Now, so you have the vector, you have the capability to run the LLM, but very often it is a case that people want to do the vector search, right? So the vector search, semantic search, distance functions, these are the same things. Because of the fact that we are doing this vector processing in HeatWave, 2 things happen. A, it's done in memory, and we have optimized it to do it at memory bandwidth. And secondly, we can scale, we can parallelize across multiple nodes. This is a performance comparison or price performance with a single node. Just taking one node of HeatWave and comparing with Snowflake, Databricks, and BigQuery, you can see that HeatWave offers much better price performance compared to any other vendor for distance function. We launched HeatWave Generative AI at Cloud World last year. We had support for in-database LLMs, which we had already optimized over the baseline. So the baseline is you take off-the-shelf LLM, you run it on a CPU, it gives you some performance. Based on that, we had already improved the performance by about 3 times by last Cloud World. Since then, we have done further optimizations by about 2x. Now, the exact performance depends upon the size of the prompt, right? So it's hard to say, but I would say that we are about between 2 to 3x of the performance of running on a GPU. So that's really good, right? Because you're getting more security, it's for free, and it's always available. One of the things which you do with HeatWave is that when someone is asking questions, the client, we preserve the state inside the database. So what that means is if you ask the system, what is HeatWave? It gives you an answer. And then you say, does it support machine learning? So when you ask it, the system knows that you're referring to HeatWave. So this context is saved inside the database, and any application which is using HeatWave Generative AI can leverage this context. One of the places, as I said, we are supporting HeatWave Chat. It's a VS Code plugin to MySQL shell. So one of the applications which uses this context is the HeatWave Chat, and it's a very interactive demo, and we have it available, which we had made available when we did the launch. And the interesting thing is we are augmenting it as we are adding more generative AI capabilities to HeatWave. We support a number of languages. So there are two things to note. One is your documents which we are ingesting, those can be in different languages, right? That's one thing. And that depends upon the kind of encoders we are using inside the database. And the second is that you may want to ask the question in some language, or you may want the response in another language, right? So that's a second class. So what this shows is the list of languages which are supported by HeatWave Generative AI, which is a combination of using in-database LLMs or the OCI GenAI service LLMs. If you were to only use the in-database LLMs, which are free, then the number of languages which are supported by Llama 3.2 is about 7. Here's an interesting use case by one of the large customers of HeatWave. What they do is that they're in the semiconductor manufacturing. When they manufacture their chips, they do some testing, and the output of the testing, the test logs, they are stored inside a MySQL database. So they've been working with us to apply machine learning to these test logs to determine which of these logs have anomalies, which would give them a sense that which of the test chips have some issue. So that's something which is already there, it's already in production. Now what they're working on with us with a POC is to apply generative AI to that output. So not only do they want to get the anomaly detection done automatically, they want to get some description of what is that anomaly. And that is possible because they have a corpus of documents. For instance, it may have the specs of the various components being used. They had the specs of, like, say, the MySQL bugs. When I say the specs, they have the documentation or the various, MySQL bugs and such. So by applying the LLM on this vector store or this corpus of documents and looking at the anomalies which are being flagged, they are now able to get a description of what that anomaly is. So this is something which significantly saves time if you think about it, right? I mean, if you have a million chips which you're manufacturing every day, in the past, one would need to write scripts to figure out where the anomalies are. But the nature of the anomalies is you do not know, right? What is the new anomaly? But the system figures out what the normal baseline is and what the anomaly is. So that itself is very rich. And now you can get a more detailed description about perhaps the root cause of this anomaly by applying generative AI. When we talked about us announcing the HeatWave or the MySQL REST service, this is a very powerful way for you to now deploy applications on the client without a mid-tier and leveraging all the capabilities of generative AI, machine learning, and JavaScript inside the server. And Sandeep gave a pretty good demo about it, so I won't talk in more detail. But what I do want to share with you are the performance implications of this. Not only are we offering this thing out of the box for free, and it's very simple to use, but it is also very performant. So if you look at the comparison, the first comparison is for the static files. It is quite comparable to the Nginx server. It is better than Apache. It's comparable to the Nginx servers. And when the load or the concurrency gets to be high, at some point, it starts getting even faster than Nginx. So I would say it's about comparable to Nginx. And the second thing is that if you were to do the comparison of the performance of the REST service by developing an application yourself, you can see from the throughput, the y-axis, the number of requests it can serve, the performance is fairly good. So I guess one of the things, the message over here is that not only do we have this offering, it's fairly well optimized, and a ballpark, just a ballpark, is we are able to serve about 100,000 requests on a server with 64 cores. Everything which I talked about, vectors creation, vector processing, generative AI, invoking external LLMs, in-database LLMs, all of this is available obviously in OCI, but also in AWS. The only difference is in AWS, we have done the integration with AWS Bedrock. Let's see if I have time for it. Okay, so basically to wrap up, first thing to note is that HeatWave provides the best performance and the best price performance in the industry for analytics, for machine learning, and for vector processing. Secondly, regardless of whether you have your data in the object store or in the MySQL database, MySQL applications can run on both the data sets And the data from the object store is not copied to inside the MySQL database to perform any of these operations. For MySQL workloads, HeatWave provides the best performance and the best functionality. So many of the improvements we have made in MySQL are cloud specific. So if you have a MySQL application, you're going to be best served by moving to HeatWave because that will provide you the best performance, the best price performance, and the richest functionality. For instance, like auto indexing. The built-in support for generative AI in vector store, that's something which is very interesting. I'll tell you this, just like any other manager, I speak to a lot of customers, and at least in the last 6 months, I can't recall any conversation with the customer where generative AI was not a part of the solution. So what they were like, okay, we want to do analytics or we want to do transaction processing, but tell us what is going to be the roadmap for applying generative AI on the content which already exists or the content which they're going to bring in. So if you're not already thinking about generative AI, you should start thinking because chances are the competition is already working on it. And finally, all this functionality is available, obviously in OCI, but it's also available in other clouds. In AWS, it's available natively, where natively meaning we run inside AWS, and in Azure, it's over the interconnect. So with that, I'm happy to take any questions.